Hi guys, welcome back to Shree Mukambika tutorials. So in this lecture we'll be looking at few properties of circles. When I say about properties of circles, I mean first we will look at different types of circles we can have. Okay. So the first type is congruent circles. Okay. What do you mean by congruent circles? If the radius of two circles or the radii of two circles are equal, then the circles are said to be congruent. So over here we have an example in which we are having two circles with radii OP and OR and having radius 5 centimeters each. Moving on to the next one, make sure you pause this video and make a note of this. Okay. Next thing, we are looking at concentric circles. Okay. Now, what are concentric circles? In concentric circles, the circles have the same center but different radii, and that's why they are called concentric circles. In other words, I can say that their radii are not equal. So, for example, over here we have three circles with three different radii. OA, radii OA is the one which is marked in green, then radii OB which is marked in red, and radii OC which is marked in black. Okay. So the green circle is formed by radii OA, the red one is formed by radii OB, and the black one is formed by radii OC. Now all these three radiuses are not equal. Also, there's another relation between them. Radii OA is less than radii OB, which is less than radii OC. Okay, so make a note of it. Moving on to the next slide. Now, we come across intersecting circles. So, what are intersecting circles? Coplanar circles having 2 points in common are called intersecting circles. So, for example, the bigger circle and the smaller circle, when they coincide or intersect, we are having 2 points in common that are A and B, point A and B. The adjacent circles are intersecting in two distinct points, A and B. So, these are what intersecting circles are. Moving on to the next one, touching circles. So now there are two types of touching circles. One, when the circles touch internally. Okay. Another one, when the circles touch externally. When I talk about touching circles, I mean that two circles only meet at one point or they intersect at one point. Okay. So coplanar circles intersecting in one point are known as touching circles. Circles touching internally is given towards left, and the circles touching externally is given to the right. Moving to the next one, circles passing through a given point. So infinite numbers of circles can be drawn passing through a given point, and the radii of these circles may be same or may be different. So one example is given here. We have point A and three circles have been drawn through there. So infinite numbers of circle can be drawn this way. So the next topic is infinite circles can be drawn passing through two distinct points. So for example, we are having two distinct points A and B. What you can do is you can join these 2 points. We get a straight line or segment AB. Now draw a perpendicular bisector to segment AB, and then you can have infinite circles drawn through two distinct points. Okay. The example is given over here. What if you are given three non-collinear points? Consider this example where you have three non-collinear points A, B and C. So one and only one circle can be drawn through three non-collinear points, and this circle will be unique. You can't draw more than one. Okay. And in case you want to find the center of this circle, what you have to do is you have to make perpendicular bisectors of the segments joining these points. That means you have to draw perpendicular bisector for AB, for AC and for BC, and the point where all these perpendicular bisectors intersect, you will get the center of the circle. Now let's talk about tangent. So what is a tangent? A line Tangent is basically a line which intersects the circle in one and only one point. So over here we have that point as point Q. So line L is the tangent to the given circle passing through point Q. So let's talk about secant now. The line intersecting the circle in two distinct points, P and Q, is known as the secant. So in the given example, we have line L which intersects the given circle at two different points, that is P and Q, and it forms a secant. Okay. So basically the secant passes through the circle. Now we will come on angles subtended or formed by chord. Okay. So we have chord PQ in the given circle with center O, and there's an arc, minor arc formed PXQ. Okay. So chord PQ forms an angle with point O. The angle is called angle POQ, and it is formed with the center of the circle, as O is the center. This angle is called as central angle. So measure angle POQ at the center is the central angle. Now we can say that measure of arc PXQ will be equal to measure angle POQ. If point A lies on the circle, okay, if point A lies on the circle and this time chord PQ forms an angle with point A, so the angle formed will be called as measure angle PAQ. Then this type of angle is known as inscribed angle. Okay, so measure angle PAQ formed is equal to half of measure of arc PXQ. In the previous slide, we saw that measure of arc PXQ was equal to measure angle POQ. So over here, one relation we can derive between inscribed angle and central angle is that inscribed angle will always be half of central angle. Moving ahead, if point A lies randomly inside a circle, in the interior of a circle, we can say that chord PQ subtends an angle PAQ with a point in the interior of the circle. And if the same point A lies outside in the exterior of the circle, we can say chord PQ subtends an angle PAQ with a point A in the exterior of the circle. Now coming to the diameter properties. So let's discuss few things about diameter of the circle. This holds really a lot of importance. Okay. A chord passing through the center of the circle is called a diameter. So you can draw infinite number of diameters as it passes through a point O, which is the center of the circle. Diameter is also the longest chord of the circle. Now, diameter and radius have a relation. Diameter is 2 times the radius of the circle. And what does a diameter do? A diameter divides the circle in two equal semicircles. And each semicircle measures around 180 degree. Okay. So if we see at this example, we have got diameter PQ, which divides the given circle in two equal semicircles, which is measure of arc PXQ and measure of arc PYQ. These two are semicircles with each being of 180 degree. Moving to the next part, diameter also subtends right angle PAQ with the point on the circle. So point A lies on the circle, on the circumference, okay, and diameter PQ forms 90 degree with it. So measure angle PAQ will be equal to 90 degrees, which is equal to half of measure arc PXQ. So measure arc PXQ in the previous slide we saw it was equal to 180 degrees. So if we half it, we will get 90 degrees. What if point A lies in the interior of the circle? So if point A lies in the interior of the circle, then diameter PQ subtends an obtuse angle PAQ with the point inside the circle. That is, so that means measure angle PAQ will be greater than 90 degrees. That is, it is obtuse. Moving to the next case in which point A will lie in the exterior of the circle. Diameter PQ will form an acute angle PAQ in this case. So measure angle PAQ will be less than 90 degrees. That means it is acute. So make sure you draw all these diagrams in your notebook and note all these properties, okay, and by heart it. So once we reopen, we can use these properties in our numericals. Thanks for watching this video. Make sure you like this video, share with your friends and subscribe to our channel, and stay tuned for more updates. Thank you so much.